Hi, it's Gadget UK here again, back with something else Commodore. It's yeah, I'm going to part this. It might just be that the screws are a bit loose. It could be that the screws have been, you know, the posts are broken off inside. You can see the wires hanging out there. The plug is missing its top. Never plug a plug in like this. Obviously it's missing the earth. Well, the earth was in the packaging somewhere, but it will need a new plug. And it's missing the connector off there as well. Now, it just so happens that Jeff Birt sent me, is it Jeff Birt? T Birt? Hello, hi Birt? Jeff? Yeah, Jeff from Hey Birt, I think it is. Yeah, I'll stick it there. And a link down below. Sent me some connectors actually, brand new ones. So I'll have a go at fitting one of those. I think it's got a black housing on it, but that doesn't really matter. This is the heavy type. So there are a number of these. So this is the first time we've been inside one of these on my channel. So without further ado, we'll get the screws out. So the screws seem to be coming out, so I don't think the support pillar is broken off, which would suggest someone has been inside it. Now I think, I could be wrong, this is the one that outputs the lower amount of voltage current here. Yeah, look, 4.3 amps. I think some of them will output 5 on the 5 volt side, and the plus 12 is 1 amp, minus 12 is 0.1 amp. Now I could be wrong, I'll compare that to one of the other ones in a minute. I've got a few here that I need to recap and service really. But the nice thing is with these is they are serviceable. You know, the newer ones, as I'll show you in a few minutes, are not easily serviceable. You can get into them. You have to super glue the base or epoxy the base back on, which is a bit of a safety sort of hazard really. But they're non-serviceable, the newer ones really. So if we carefully pull this apart, I'm not sure, let's try and pull the top off. Yeah, so look at that giant transformer on there. And then you can see all the caps and things down here. It's huge, that thing. There you go, so I carefully lifted it out and put it on the mat here. It's pretty wieldy to handle actually because of the transformer. Be careful you don't touch any of the contacts there with your fingers, because you could get a shock. Although, thinking about this, you can have lower voltages on here. Well, yeah, I think you are. Don't quote me. We'll have a look in a minute at the voltages of these caps. But because there's a transformer here, this is stepping down from the primary mains input to a lower voltage. You know, there'll be a lower AC voltage comes out of this, or a number of voltages, because look, there's a few windings here. There's more. It's not just 2 contacts. You've got 5, I think, there. So just rotating it around a little bit, having to hold the transformer while I do this. Yeah, you can see the components here look okay. I don't see any swollen caps or anything like that. You might want to check the ESR out of these, but I think these are probably going to be okay, to be honest. I don't think that's going to be the issue. Something could have failed. There's a couple of little ICs here, perhaps for regulation and stuff. It's worth also inspecting the underneath here to see if there's any bad solder points, but yeah, it's not looking too bad. Yeah, so there are 1 or 2 like this here. I don't know if you can see, it kind of just looks a little bit questionable to me. I mean, it's not a bad joint, but yeah, I would reflow 1 or 2 connections like that. That might be one of the wires that goes to the windings or something. I can't quite see what that goes to. No, it's not. It's a cap or something actually on the underside that goes to. Anyway, I'll solder 1 or 2 points here, clean up and stuff. Then I think we'll just get it back into the casing. I'll put a safe fuse on there, replace this dodgy blooming thing. Strip off the ends of the wires here, separate them all so they're not shorting, and then power it up and just see what's happening. I'm suspecting the power supply might actually be okay. It might just be these connections here. So I found a plug. It's super battered and pretty dirty. We'll just check the inside. If it's okay, I can clean up the contacts here with fiberglass pen. Yeah, it looks alright. I've just got a 13 amp fuse, so we'll take that out. What was the other one? Was it 3 amp? It should have a 3 amp fuse this. I think that's a 5 amp, isn't it? By the looks of things. Let's just take that out anyway. Let's just see what it is. It's not going to come out, is it? Well and truly welded under there. So if we just get the old fuse out of there, it'll come out. 1 amp? Good God, I didn't think you could get a fuse in that size like that, in that cartridge size or whatever it is. Now let's just test the fuse. I mean, it might be that the fuse went, because 1 amp is... Yeah, that fuse is blown. Yeah, so I've got the meter on continuity test here. If we touch the probes together, they're okay. Put them on here, open. That's blown, and the reason that's blown is 1 amp is probably too low. Typically in British fuses like this, British plugs, you'll see a 3 amp, 5 amp or 13 amp. Those are the 3 sizes we use. I've never even seen 1 amp in that size there. That's probably why it's blown. So let's get a 3 amp fuse and try it. So I've got a brand new 3 amp fuse here, got it on continuity test again, and we've got short. So that's good. So we'll stick that into our new plug. There we go. So what you want to do here is unscrew the screw until it's the hole inside is maximised in terms of its gap. Can you see? If you just look down there, can you see the little thread? Just pull it back out like that, so you've got a nice large cavity for the connection. Same on the earth and the live. This one's the earth. There we go. So I'm going to use this screwdriver on this one. God, that's well and truly mangled there. Can you see that? It's hanging on there by a thread. So that was never very safe right from the start, actually. Right. You've got the strain relief here that's holding the main part of the wires in. It's pulling them in to the sensor. So if we just undo those. Next thing I'm going to do is just undo the cable relief on the new plug. Well, the new old plug. I mean, I could undo it completely, but we'll just shove these wires through there. I might need to just trim these down a little bit because I don't like the length of 1 or 2 of them actually. So the way a plug like this should be wired, your live should be the shortest. So you see how long this is? This is crazy long. It wants to be just long enough to go from where it is there now into the terminal block, thing like that there. So the best length for that is about that long. Just trim that off. And bear in mind, the way this is fed, it's not really the right way. It wants to be around like that, otherwise your wires are twisting around each other. I'm going to take that cable relief off because it's just annoying me. So now we've got it like that. If we just move these around a little bit, it's going to be like this here. Yeah, that's about the right length, I think. So if we now trim back a decent amount on that, like that, there. Just snip into the edge. Careful not to try and cut the actual strands in the sensor there. Just the plastic edging, the plastic sleeving, and then pull it off like that. We'll get some solder on that, and I'll just tin it. It's always a good idea because it gives strength. It strengthens the connection there instead of just the single strands. So you can see those have been tinned already. The green and yellow, which is the ground, the earth. That's been tinned already, and so is the neutral there. But what I would say is you don't need that much of a length, so trim the neutral down a little bit. The earth is okay there, that should be alright I think. So I've fed the live in, as you can see, and we'll just tighten it up. I'll need to use the other screwdriver to make it super tight. And the neutral, again, you could argue the neutral is quite long. It doesn't need to be crazy long because actually the neutral could reach up to the earth. This is why the length of these is super important. So would you put that where it's going to be? It's going to be about there. So I would suggest pulling this around like that and trimming off to, I don't know, about here. So let's just do that. Let's just trim off that bit. Again, you could argue that maybe that's slightly longer than it should be anyway. I mean, it's going to be held here with the cable relief, but it can't get up there now. That's the main thing. Just using this as a screwdriver because it just gets these super tight. There we go. You want the earth kind of like that in length, so that the wires pull, this will come out, the live will come out, but this won't. This will have a bit of, until you've pulled it quite a long way further, so the earth remains connected all the while. So yeah, we'll just trim it there and do the same thing, just trim off the covering. And the same thing again, feed it in, push it down, and tighten it up. And we get our cable relief back on, which means putting the screws through here. That's one side. resoldered one or two of the points around here, so I've just been cleaning those with IPA and a cotton bud. But I'll just go over any of the points on here that I think need it. For example, there's a few marks like that there, you know, just a bit of flux that just looks messy. I'll clean it off. So bear in mind, with a power supply like this, you're going to have a winding across here. So you can't do what you might normally want to do, which is to test continuity between live and neutral. Because you will, I'll show you, it's not dead short. You will have a short there. Yeah, that looks like an inductor to me, you know, a coil. That's the sort of reading you get with a coil. So that 27 ohms. So that just gives us an idea that the primary winding's probably okay. If you were seeing like 3 ohms there or 2 ohms there, I wouldn't plug it in, it's going to blow. And certainly make sure you've got, you know, a 3 amp fuse, you know, or a 1 amp fuse actually, if you can find one. That 1 amp fuse has probably been in there for a long while, you know, and it's only blown over a period of time. I think with the grommet here we can actually repair this. If we get some epoxy around the circumference of the end of that cable there, I reckon I can just push that back there like that and just leave that, and I think that that'll set. So the next thing I need to do is fit one of these connectors. So let's have a look at this. There's enough parts here for 2 of these. So we've got a housing each, centerpiece each, grommet each, one of those bits and one of these bits. So just put those out of the way, that's a spare one. Yeah, so you basically stick that in there, obviously join this up here. It's got a little plastic notch on it somewhere. Yeah, this is the side. Yeah, this side here has got a little indent there. Can you see which will go this way? So if I just pull that wire out, it should go into there like that. Can you see that? So we just need to, like I say, strip this back, measure the voltages, work out which one needs to go to where and here, and join them up. Then put the top piece on and slide this, but you need to put this on first. This is the thing I always forget with these. I hate these darn things for this reason. There's 2 elements to this. There's the cable relief, which I think, let's think about this. Yeah, so you stick one end in there like that. You can just twist that in. There we go. So there's our grommet. And then this needs to go over here like this. It's pretty stiff that already, and that's a good sign, because it'll mean it's nice and tight. So we can just forget about this now, slide this up afterwards when we're done, and just work with this. But the next thing we need to do here is, well, I've got to think about this. If I've got this here, and this goes here, I want to make sure I've just got enough length here to go to that. So I'm just carefully snipping into that there. Yeah, there we go. So we've got like a shield blade on the outside there, look. Pull that back. So then we've got a shield there, and we've got 1, 2, 3, 4 cables. I'm guessing the black is going to be ground, and then it's just a question of what these are. I'm guessing red 5 volts, I don't know, plus 12 and minus 12 being white, maybe. Be nice if they went with some sort of logical colour system there. With it being a Commodore device, I suspect they probably have done, to be fair. So we'll do the same thing we were doing with the other ones, just twist them together like that and then tin them up in a sec. The thing is with this, there's not as much chance of it exploding, you know, something blasting out, but you know what, play on the safe side of things, have things, you know, protect yourself just by putting the lid back on before you try and test it. Bear in mind I haven't fixed this yet, I'll do that last. And we'll go plug it in and measure the voltages. So hopefully you can see this. I'm just going to very carefully try and measure from the black to the red. So from the black to the red, 5 volts. From black to white, minus 12. Brown, come on, plus 12, where are you? Plus 12. There you go. They're bouncing around because I can't keep the probe on there with any kind of meaningful pressure. So they are, as I thought, it's ground, red is 5, white is minus 12, yeah, brown is plus 12. So from the back of an existing power supply connector, you know, looking at it like this, with the notch at the top there, I measured, worked out that the ground was the top right. If you measure between that top right and bottom right, you get 5 volts there, so that's 5 volts. Between the middle and ground there, you measure 12 volts. Actually, on the one I was looking at, it's one of the lighter weight power supplies, it was showing about 14 volts there, minus 14. And up here, plus 14. So that's plus 12, minus 12. And then down here, I measured, and this from connectivity from this bottom left pin to the shield, and there was a short. So that's the shield, it's the screen, you know, the sort of grey, there you go, silverish wire there, that's going to go there. So that's something to all 5 connections, so that's it. So all I need to do now is maybe use the helping hands here and grip this here like this and solder the wires onto the relevant places there. These are kind of pre-filled, can you see that, with a little bit of solder in the holes there? So it should be pretty easy, I think. It's just going to be a case of heating it and then try and push the wire in. Just make sure you've got your housing on there before you start, because it will just be a pain, an absolute pain if you haven't, because you'll have to disconnect it all again. So we'll do the ground first. I'm just going to add a little bit of solder, but we shouldn't really in theory need to add any actually, because it looks like it's kind of, yeah, there's already some there. That's the black done, I think. Hold it there for a prolonged period of time, because the temperature, you know, these things stay molten for quite a while. Yeah, that's okay, but we've got a little bit of solder just there. I just want to trim off if I can. Yeah, there we go, it's gone. We'll do 5 volts next. 5 volts is down here, so let's just connect it back up to this again. So again, not some of my finest work, but yeah, it's getting there. We've just got the last one now, which is the shield. So with the shield, you know, I've tinned it up a little bit, as you can see, and I'm just sliding some heat shrink tubing over, because what you don't want is that shorting to anything else around there. It's going to be quite fiddly, this, because we need it to, you know, sort of come around this way and bend it, and it's really stiff again. Solder iron's super taut here, the cable. We need to heat that. Oh, good God. And then kind of push it in. Yeah, I think that's it. Hold it until it cools. Maybe wet the pin with a damp finger. Yeah, that's okay. And we can just pull that heat shrink down a little bit, I think, and then just heat it with some hot air. To be fair, I think that's alright where it is, but it would be nice just to try and move it a little bit this way. Yeah, that'll do. So if we just clip this back into its housing, this is where a bit of manipulation might be required, because can you see it's not going straight up, so you might need to just kind of like, I don't know, twist it a little bit depending on where the wires are pulling it and stuff. So yeah, that bit goes there. This is the strain relief, you know, so if we kind of bend them in and down a little bit if we can. But you want it to grip at the top, so you want to sort of crimp downwards like that there, and then do the same on this side here, you know, crimp it in and down like that. Can you see that? And then maybe squeeze them together a little bit. And there's another cable relief at the top here. Can you see these two bits? So again, these need to be bent together. Yeah, that's about as good as that's going to get. That's very tight, no issues there. So it's probably worth at this point adjusting a little bit. So grab that piece there and just twist one way or the other. Can you see I straighten that out a little bit? And then get this piece on. Forget where this goes now. Goes that way, doesn't it? Like that. Yeah, that's it. And then we can slide this up. Can you hear that's pretty tight? Now it's only going to go one way, this. Can you see that plastic notch there? We need to marry it up somewhere. I'm not really sure where. I think it's here, because I think it goes into that recess there. I can't see where else it would go. So if we carefully just push this in, it's going to go so far until that clips in. There we go. Yeah, that snap. There we go. Fantastic. So let's go and give it a try. I'll measure the voltages first, just to make sure I've wired it correctly. Hopefully I've done everything right there. I'd hate to have to take it back to bits again. So as you can see, it works. It's powering the system. So measuring from ground over there, I'll try not to block the meter. If we check that first connection on the choke, see that, plus 12, the next one, minus 12, and the next one, plus 5. So we're all good. And we will see how clean it comes up. Obviously there's going to be, it's going to look greyer under there than it does on the rest of it, because the sunlight has got to the bits that weren't covered by that sticker. So stuck it in the sink there with some vanish oxy action. We'll leave that for about 20 minutes. So it's been drying overnight. I put some epoxy on there, and that's done the job. That's really stiff and sturdy. And the case is all dried now, and you can see it looks pretty good actually. You can see where the label was there, but it looks almost good as new. That there are a couple of chips. Can you see this here? It's had an impact. You know, it's had an impact in these corners here because of the weight of the transformer. It's just got a little bit chipped off there. So I'll just get a little bit of epoxy or super glue, I think, perhaps epoxy, just into the little gap there, and then just push it like that. Maybe peg it or something. You know, use something to hold some force on there until that's dried. But that's all really. Well, the super glue's not working on that plastic. I can clean off the little bit there with some plastic cleaner in a minute. You know, I'll get that uneven surface off there. But what I can do is just force it like that, and then use the soldering iron and just touch the very edge of either the corner here. So I don't want to distort the outside, so you won't see it on the outside. But just touch it in a couple of places, just to hold that. It's not going to look perfect because, you know, it has been bent out a little bit. This one here will be a bit easier because it's just a super small fracture. Again, just to, you know, press it together and then just touch into the edge of the corner there with the iron. Pull away, hold it, let it cool down, and let go, and it should be okay. Yeah, there you go. So that's that one fixed. I don't know if you can see. There was a super fine fracture there, but it's gone. And all I did is, as I say, just touch it in the corner with the soldering iron, and then just touch the surface here just a little bit. Hardly anything at all, so that from the outside you can't see, but that's actually fixed now. If we just carefully try and get this into position now, you might need to wiggle it around a little bit, although it feels to have almost gone straight back on with that issue actually. Yeah, after a bit of manipulation there, it's gone back together okay. So there we go, she's all back together. As you can see, that grommet there has held really, really well with the epoxy. It's gripping that really super well. And we've got a new connector there and a cleaned up plug here, as you can see. Yeah, it's a bit yellowed on this side, but you know what, it's better than it was. So it goes without saying that while you're in there, you may as well recap it. But, I mean, I've shown it so many other times on other videos recapping things, there's just no point. I'll be using this for a period of time, but I'm going to keep this as a spare. So here's one of those other power supplies I was talking about. These are the ones that I think got bundled with the 600, the A600 and the A1200. Maybe even some of the 500 pluses, I don't know, because Commodore sort of, you know, swapped around what they bundled with things at various points. You know, you can see the grommet's broken off this one a little bit here actually. So I don't know if you can see the difference there. Look at this, 5 volts, 3 amps. That other one was 4 point something, wasn't it? 12 volts, 500 milliamps. It was an amp on the other power supply there, the heavy brick one, and minus 12 volts, 100 milliamps. I think that's the same. But you can see, you know, there's no way into this. What you've got to do with this is you know, chip around here, use a knife, a sharp knife, scratch around all the way around the edge and try and prise the base off. It's like, and it's really, really heavy. It's heavier than that other one. This one, believe it or not, it's probably, well, they're about the same actually. But this is like potted, you know, they fill it full of like a resin epoxy stuff. It's like really hard, you know, you can't scratch it, you've got to like chip it and dig it all out if you were going to, you know, I don't know, do something with this. Feels like it's got a transformer in it, probably. It'll be the similar sort of thing with this transformer, maybe a few caps, some sort of, you know, basic regulation. But I prefer the lighter ones. And this is one of the lighter ones that I like. You know, the weight difference between these, this one on the left here, with the transformer, it's 3 or 4 times heavier, than, maybe 5 times heavier than the one on the right here. And looking on the underside of this one, the light one, 5 volts, 4.5 amps, 12 volts, 1 amp. Yeah, you see that other one was half an amp, wasn't it? And the minus 12.1, that's the same. And the interesting thing is, you know, you comparing the part numbers here, you can see the 312503, this is the lightweight one, dash, there's nothing on the end there, this one's a dash 02 here. Yeah, and the 5 volts 4.3. versus 4.5. This is why the light ones are more desirable. But you know what, this is fairly close to the lighter one anyway. Certainly better than this piece of shit. So not a bad pickup. It was only £5 or £6 this. Thanks to Hey Birt. I'll post a link down to his channel below for this connector. So I didn't check the AC ripple on this. That's one thing you should perhaps do. But you know, recapping that ultimately would solve it. But if you put your multimeter on AC and just measure between ground and each of the voltages and see what voltage AC you get, you know, if you get more than, I don't know, 10 millivolts, for example, something around that or more, then yeah, it's an indication you need to recap it. I'd be amazed if any of these, even when they're being recapped, have got less than about 5 or 10 millivolts of ripple, to be honest. Anyway, thanks for watching. I'll catch you in the next video. So I'll remove that pat testing sticker here, and we're going to go wash this in the sink. I'll soak it with some Vanish Axioxin. What's Axioxin?